installment, we're going with the blandest, the boringest, the most abundant, and it is quartz. And actually, I was joking, it's not boring. There's more gemstones that are just the composition of quartz, SiO2, than anything else. And so we're going to put here that they are many varieties of quartz. In fact, it's so hard to even list them all, but we're going to do our best. Normally, when we picture quartz, this is what we imagine, this image from Wikipedia. We see the variety called rock crystal, which are clear euhedral crystals. They show a hexagonal or six-sided columnar with a pyramid on the top. But there's so many other varieties, and one of the reasons why is it is the most common, well, not mineral on Earth, but in like the surface of the Earth. It's basically the most common mineral at the surface. We'll say this, most common mineral on the surface of continents. We live on the continents, and so that's usually what we think of when we think of Earth. So it's the most common mineral on Earth, on the surface of Earth. When we think of quartz, I want you to think of all the sand in the Sahara and the sand on every beach, the cobbles and gravels and sands in a river. All of this is primarily quartz. So we want to think of all the grains in the desert. That's not even close to being spelled right. In the deserts, in the rivers, in the beaches, in granite, in the sandstones. All of this is primarily quartz. So many metamorphic rocks have quartz as well. That is just so prevalent. Have I made my point clear that it's common? And with it being so common, we can break apart the gemstones of quartz into three categories. And we're going to do that here. Categories. The first type is we're just going to call single crystals. Then there's a variety of gems that are made of SiO2, quartz, that are microcrystalline aggregates. Microcrystalline aggregates. And then there's cryptocrystalline aggregates. We're going to list them out here under this. Here's a table. We're going to go down. And when we think about the crystals type, we have the rock crystal quartz. That's the white clear type, all right? That's colorless. Then here's where we have our famous amethyst. This is where we have citrine and rose quartz and smoky quartz. All of these types of quartz can be cut into gemstones. They're probably the ones that we know the most. The microcrystalline aggregates, the most common or famous gem type is called tiger's eye. There's also aventurine, which we're not going to talk about, but we'll put it here for completion's sake. And then the cryptocrystalline aggregates, the general name for these is chalcedony. Okay, that's the general term. Put a little star next to it. But there's a lot of specific types. There is agate, and there is carnelian and jasper. Carnelian. We have jasper. We have onyx. What other types do we have? Well, we'll get to them later, right? Now, what's the difference between a single crystal, a microcrystalline aggregate, and a cryptocrystalline? Well, with a cryptocrystalline, you must have a microscope in order to see the individual crystals, right? They're very, very fine. Microcrystalline, you can see them with your naked eye, but they're very fine. So we'll just say fine grained. And then these are actually like large crystals. They're either euhedral or anhedral masses. My notes got a little sloppy here. Keep yours nice and clean. In culture, that's usually one of our headings that we do here. Oh, is this B? This is supposed to be B, our three categories. C is culture. Where do we see amethyst in culture? Oh, well, I guess we can just go ahead and put that. Amethyst, this is the birthstone for February. And that's the one that's the most famous, of course. It's very affordable, occurs in many colors, and has a lot of great properties for jewelry with its hardness. Now, another aspect in culture, it doesn't relate to gems, but it's certainly economic, is called piezoelectricity. And the fact is that quartz is piezoelectric. It's this weird phenomenon that if you stress the crystal or charge it with an electrical current, it'll vibrate at a set rate. So we can get the crystal to vibrate at set rate when a charge, an electrical charge, we'll put it that way, electrical charge, or physical stress just applied to it, is applied. And this is very important for like watch manufacturers. You can count, if you do a set electrical charge, you can actually count how fast the crystal is vibrating, and then you can count seconds away. So sometimes you'll see this on watches, and then there's other industrial purposes for this piezoelectric property. As we go through quartz, we should now get into our mineralogy. We're not going to talk about geologic occurrence because there's so many different environments. But our mineralogy will go A, composition is silica oxygen, SiO2. Such an easy chemical formula to remember. Our B is going to be crystallography. And there's going to be a lot of different ways that quartz can crystallize. There's one way is with the euhedral crystals, like so, all right? And those are, of course, the ones that mineral hunters want to go find. And so for those, we're going to say hexagonal columns with, or topped with a pyramid. And this is when they are euhedral crystals pulled from the ground. They don't have to be pulled from the ground to have like that to have value. You can certainly pull out chunks of quartz that have plenty of value that are just massive. Another synonym for that would be anhedral. We often think about rose quartz this way. I'll just put that as an example. And then there's a third crystallographic type, and that's botryoidal. Do you remember this word? Botryoidal, it's that bunch of grapes. If we drew it something like this, with these kind of all these humps stacked on top of each other. And the variety that grows this way is chalcedony. So all of our cryptocrystalline varieties are botryoidal. Our physical properties that make it a good gemstone are a complete lack of cleavage. Do you remember how quartz breaks? Instead, it breaks with a conchoidal fracture. Yeah, like the way glass breaks, right? With those smooth, curved, shell-like breakage planes. And the other thing is with Mohs, hardness, it's a 7. So it's very resistant to weathering. And this is kind of the standard that everything else is measured against in terms of hardness with respect to placer and alluvial gems. If it's a placer, so a placer gem must be harder than quartz. Otherwise, it won't survive. And then similarly, it has a specific gravity of 2.65 grams per centimeter cubed, which again is the standard. Placer gems, diamonds, sapphire, gold, anything has to be way, way denser than quartz in order to be found in a placer. So you better be harder and you better be denser because quartz is so prevalent in those river systems. Geological occurrences would be next, I would say here that we'll just go ahead and skip. So now what I want to do for this lecture and the kind of the next one, we're just going to go through all the different crystal varieties. Give each one their day in the sun. And we must start with amethyst. Here's a stunning image of some euhedral amethyst crystals I got off of Wikipedia. We can see they have purple tops and they actually grade down to a clear base. And that's one of the things that is very common about amethyst is this color zoning. So A, B, amethyst. This was a very, very valuable stone for thousands of years, rivaling ruby and emerald and diamonds. The Greeks named it after the word intoxication because they thought it would protect you from drunkenness. And so it had all this significance and value, but then it was discovered in Brazil in the 1800s that there was, in Brazil in the 1800s, a huge discovery was made. And basically the supply and demand chain just was completely destroyed by the amount of amethyst that was found in Brazil, making it very affordable, and it has been ever since. Whereas before the 1800s, it was very expensive to get your hands on amethyst. The color of amethyst is, of course, purple. Whoa, shrink this image down a little bit. That's too big. How do we do that? This is another faceted variety. I took this off of Wikipedia as well. And so the color, let's put this here. Color is purple. If it's gonna have, it can go light to dark. There's all these different variations there in terms of its saturation. But if you can have it be somewhat reddish purple, that's gonna be the most valuable. Reddish purple will be the most expensive. Like this one here, when you look at this, you just see purple. But see, notice here, there's kind of a reddish hue to this. This is gonna have a nice color that the jewelry industry would covet. The purple color comes from trace iron in the crystal lattice that is naturally irradiated. Just as it sits underground, it catches some nuclear radiation off of the rocks, and it will turn the quartz purple. All right, we're going to say here, we're going to say that vivid saturated colors are best. Of course, there's a really light variety called Rose de France, and that has value too, but we're talking like $20, $30 a carat for something like this, and the maybe faceted, whereas Rose de France is just a couple dollars a carat. When we should draw a crystal here of, how do we do this? Let's see, we got to draw a bipyramid. Here's our pyramid of amethyst. And what ends up happening is we get heavy amounts of color zoning. And the strongest, most pronounced purple occurs up in the tips of crystals. And then it gets much lighter as you go down through the remainder of the crystal. So what we want to put here is that we're going to have a little note here that says, typically color zoned. Typically color zoned. Tips, and we'll go up here and we'll say tips of crystals purple. So when we facet a gemstone, most of the time we're going to go here and we're going to try to facet our gemstone from this material right there so we can get that strong purplish color. Our sources, the top sources of amethyst remain in Brazil. In fact, what are we doing here? We'll go, that's purple, so this will be C. C is going to be sources. And we'll just say Brazil remains top source for high quality and for lower qualities. Next comes Zambia. And then on the border between Brazil and Uruguay, there's a huge deposit as well. And so what I'm also going to say here is that we're also just going to go ahead and put Uruguay. It's northern Uruguay. And at that boundary, these the famous, maybe I get in too deep here, but they're these famous, very common, you see them in interior design, amethyst geodes. They can be huge. They can be as big as like a table, or as small as maybe a globe, and you put it on your desk. That's where they're coming from. They're coming from the border between Brazil and Uruguay. There's just a huge deposit there where basaltic lavas filled, bubbles within those lavas filled with amethyst geodes. And then finally, let's just go to D. We're going to say treatment. What happens when we heat treat amethyst? Well, if we heat it, we can lighten the color. And that could be helpful if you're too saturated. But you can also heat it, turns green, or yellow. And when we heat, this to yellow, we make a new gem, which is citrine. And we're actually going to pick up with citrine and the other varieties, gems of quartz, next time.